Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing the summary of input-output resistances of different feedback amplifiers. The different feedback amplifiers, as you know, are voltage series feedback amplifier, current series feedback amplifier, voltage shunt feedback amplifier and current shunt feedback amplifier. So let us quickly summarize them. So how to remember them? So you need to remember the block diagram of a feedback amplifier. Sampling is done at the output of the amplifier. There are two types of sampling, voltage sampling and current sampling. If voltage sampling is done, the connections at the output will be shunt, that is in parallel. The feedback network will be connected parallel to the amplifier. If it is current sampling, the feedback network will be connected in series. Voltage sampling, shunt connections. Current sampling, series connections. You need to remember these 2 points. Okay. Mixing is done at the input of the amplifier. So there are two types of mixing, series mixing and shunt mixing. If it is series mixing, voltage is mixed. If shunt mixing is done, current is mixed. So you see, both are sampling and mixing are opposite. Voltage sampling, shunt connections. Okay, voltage sampling, shunt connections. Current sampling, series connections. Series mixing, voltage source is to be placed. Shunt mixing, current source is to be placed. Okay, so let us see what is the input resistance and output resistance of voltage series amplifier. The first feedback amplifier is voltage series feedback amplifier. Voltage series feedback amplifier. So what will be its input and output resistances? So how to know that? So what is the first word tells about output? What is done at the output? Sampling. Okay. If voltage sampling is done, what are the connections at the output? Shunt. If shunt connections are there, what will happen to the resistance? The resistance will reduce. For shunt connections, the resistance reduces. For series, the second word tells about the input. At the input side, what is done? Mixing. What type of mixing is done? Series mixing. If series mixing is done, what will be the source we need to place? Voltage source. So at the output side, what are the connections? Shunt connections, that parallel connections. For shunt connection, the resistance reduces. At the input side, it is series connection. For the series, the resistance increases. This is how you can remember. So at the output side, you will have ROF. At the input side, you will have RIF. So what will be the value of ROF? It will be less compared to R0. RIF will be high. So what will be the equation of RIF? RIF is equal to RI times of 1 plus beta AV. So how to use this one? AV is what? Voltage gain. Okay, I will tell about it. And what is ROF? ROF is reduced. So ROF will be R0 divided by 1 plus beta AV. So RIF is increased. It means RI is multiplied by a factor. ROF is reduced, means R0 is divided by this factor. This is how you can easily remember the equation of voltage series feedback amplifier. So what is the first word? Voltage. Output, voltage. What is the second word? Series. Series input. If series mixing is done, voltage is mixed. So input is also voltage. So ratio of V0 by Vi is known as AV. So this is voltage gain. So what type of basic amplifier is to be used? Voltage amplifier. So these are the two important equations to be remembered for voltage series feedback amplifier. Now coming to current series feedback amplifier. The second feedback amplifier is current series feedback amplifier. What's the first word telling? Output. What is sampled? Current is sampled. At the output side we do sampling. If current sampling is done, what are the connections? Series connections. If series connection is done, what will be the resistance value? What will be the resistance value for series? It will increase. At the input side, series, the second word tells about the input. What type of mixing is done? Series mixing. If series mixing is done, what is to be connected at the input side? Voltage. Voltage source is to be placed. So for series mixing, what will be the resistance value? It will be high. So at the output side, the first word tells about the output. So what will be the ROF value? It will be high. The second word tells about the input. So input resistance is high. Now what is the basic amplifier used? The output is current. Output is current. What is the input? Input voltage source. So VI. I0 by VI. I0 by VI is what? GM, trans conductance gain. Okay. So what will be RI? Here you see both are increased. So what will be? RIF is increased. So what will be the equation? RIF is equal to Ri times of 1 plus beta. What is the gain? GM. 1 plus beta GM. ROF is also increased because of current sampling. So it will be ROF is equal to RO times of 1 plus beta GM. Okay, so this is how you write the equation of RIF and ROF for current series feedback amplifier. Next, coming to voltage series, voltage shunt. Voltage shunt feedback amplifier. The first word tells about the input, the second word tells about the input. The first word is output. Voltage sampling. At the input side we do mixing. If voltage is sampled, what are the connections? Shunt connections. If shunt connections are there, the resistance will reduce. For series mixing, here the second word is shunt. For shunt mixing, what is the voltage, what is the source to be placed? Current. For shunt connections, the resistance will reduce. At the output side, we designate by ROF. So resistance ROF is reduced. At the input side, we designate by RIF. RIF is reduced. Now, what is the output parameter? Output parameter is voltage. What is the input parameter? What is the input parameter? Shunt. For shunt, current is mixed. So II. V0 by II is known as RM. That is trans resistance gain. So what will be? This is a trans resistance gain. So what is RIF now? RIF is reduced. So what will be reduced means RIF is equal to Ri by 1 plus beta Rm. ROF is reduced. ROF is reduced means ROF is equal to R0 by 1 plus beta Rm. 1 plus beta Rm. So RIF and ROF both are reduced in voltage shunt. Now next one is fourth feedback amplifier is current shunt. Current shunt feedback amplifier. What's the first word? Output. What's the second word? Input. First word is sampling. Current is sampled. If current is sampled, what are the connections to be done? Series connections. And at the input side we do mixing. If shunt mixing is done, what source is to be placed? Current source is to be placed. So at the output side we are having series connection. For series connection, what is the resistance? Increases. At the input side we are having shunt connections. Shunt means the resistance will reduce. So at the output side we designate the resistance by ROF. So ROF is increased due to series connection, and RI at the input side the resistance is designated by RIF. RIF is reduced. So what is the output parameter? Current. Input parameter is current. The ratio of I0 by II is known as AI, current gain. So what is RIF? RIF is reduced. Reduced means RIF is equal to RI by 1 plus beta AI, whatever is the gain here. And ROF is how? Is increased. Increase means ROF is equal to R0 times of 1 plus beta AI. So these are the equations of RIF and ROF for current shunt feedback amplifier. So it's easy to remember all the equations. So for voltage series, what you got the equation of RIF? RIF is equal to RI times of 1 plus beta AV, and ROF is equal to R0 by 1 plus beta AV. Now coming to current series. For current series you got the equation for RIF is equal to RI times of 1 plus beta GM. ROF is equal to R0 times of 1 plus beta GM. This is for current series. Next, for voltage shunt we got the equation of RIF is equal to RI by 1 plus beta RM, and ROF is equal to R0 by 1 plus beta RM. Now coming to this current shunt, RIF is equal to RI by 1 plus beta AI, and ROF is equal to R0 times of 1 plus beta AI. So these are the input output resistances of all the 4 feedback amplifiers. This is for voltage series feedback amplifier. This is for current series. This is for voltage shunt, and this is for current shunt. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.